We are on lesson 15. It's the last one of our unit 1. And the goal is to compare statistics for data sets. You should already know what statistics we learned how to calculate, what they describe. Now we're just using them to compare. So you will know you're successful if you can compare and contrast situations using measures of center. So table 3, what are some measures of center that we talked about? All right, and then one more major one. Not a measure of center. Mean, yes. All right, so those are our measures of center. And then table 4, what are our measures of variability? And then all right, are there any others? Good. So that's step 1. Knowing what measures of center are, knowing that it's the mean and the median that describe that. So they describe where most of our data is centered around. And then measures of variability talk about what about the data? Like anyone. What does measures of variability talk about? How spread out the data is. Therefore, IQR, standard deviation, MAD, all of those, the higher it is, the more spread out it is. So those describe how spread out your data is. All right. That's step 1. You need to know that. I am recording right now. It'll be linked in the slides later. The practice will be lesson 15. And friendly reminder, I've talked about this already, but I'll just remind you again. The binder check is Tuesday. Including today, you should have 12 pages total, and it tells you like what it was titled. The titles are all in the top right corner. And it tells you how many pages it was. So only one of them was more than a page. And yeah, make sure that you have them. If you were absent, you're still responsible for that. You still have to take the same test as everyone else. You still have to learn the same things as everyone else. All the lessons are recorded. All the notes are in Schoology. So you are more than capable. You do not need the papers that I pass out. You can do them on your own paper. So when I know on Tuesday, I'm already going to hear it. Oh, I was absent. Oh, I didn't have the papers. That's not an excuse. So questions on that? Okay, so that is a good chunk of your grade. I only put binder checks in the project category. We don't really do other projects other than that. So that's going to be 20% of your overall grade. If you choose not to take any notes, and every year there's always like at least one person that chooses not to take any notes or chooses not to save their notes, whatever, the highest grade you can get is literally a C. And that would be you getting really high scores on everything else if you choose not to take notes. Really? I just need to see all the note sheets. I just need to have binders are better because then you don't lose them. They all have 3 holes, and you can like put them in, not lose them. But whatever. I just need to see the pages. I'm counting them. I'm checking to see that there's stuff written on the parts that we went over. Not everything has to be completely filled out. I know we don't always completely fill out the note sheets. That's okay. Whatever we covered in class, I expect to see on there. Any other questions? So then we have unit test scheduled for Wednesday. You don't get to use your notes on the unit test, just so you know. So use them now, memorize the notes now. On the test, you can't use notes. So for all of you. All right, then now for the warm-up. You are supposed to choose 2 people to be on your bowling team based on their statistics. So table 5, can you tell me one person that you think would be a good fit? I don't know. And why player C? Okay, so visually on their histogram, they are one of the higher scorers. You can tell that visually. Any other reasons that we could pick C as a good player for us, Ron? And what tells you about consistency? What measurement? Okay, so you're saying, okay, thin width is how wide the histograms are. So like this one, it looks like our bin width is 10 because each bar is like 10 numbers, right? I would actually argue that this player is not as consistent as other players. Can anyone tell me why? Brian?
Consistent and not
And what is a good measure of consistency? Yeah, the standard deviation and IQR also measure spread outness, but the fact that these tend to be higher than some of the others, so like higher than A and B, not as high as C for this one. But that actually means that C is maybe like the third most consistent. So I wouldn't say he's the most consistent. He's like the third most consistent, assuming it's a boy, I don't know. But they do tend to score higher. So it just kind of depends what you look for in a team. Do you want higher scores most of the time, or do you want them to be more consistent? Or both? That would be perfect if it was both. But are any of these players both? So there's really no wrong answer. You just have to be able to justify it either way. So then raise your hand if you chose player A. All right, what makes them a good candidate?
It's like somewhat like person C, but a little bit less consistent.
So more consistent actually, because their standard deviation is lower than C. Because theirs is lower. So a little more consistent. Any other good reasons you guys could think of? That would be probably why you picked that one. Let's see. Why would someone pick person B? Ryan? Most consistent. Right? They have the smallest standard deviation and IQR, so they're hitting these scores more consistently. Any other reasons why? Someone else? Someone else that chose B? What scores do they usually get on average? Learning me that no one knows. So I'll repeat the question. Person B, what score do they normally get on average? Brooklyn? Okay, what is their average score? Harley? No. 131.08. Because what's another word for mean? Average. So yeah, they are a higher scorer. Not the highest, but they tend to score higher. And at a more consistent rate. This right here means that's what they're averaging. So does that change anything for you? Would you prefer someone else now that you know mean is average? When would we prefer to look at the median over the mean? Table 7. When would we prefer to look at the median over the mean? I'll give them a little bit longer to decide. So like, if mean means average, and I have a mean for all of them, why do we even bother putting the median? Why would we care? When would the median be useful over the mean? Is it done? Maybe a little bit with the standard deviation, although median usually pairs with what for spread? No, median goes with the IQR. Right, so if the median's better, then we would prefer to look at the IQR. So Jaden, help him out. When it's not symmetric. So when it's more skewed, like over here, this person got a perfect game, that might be why you would choose B, because one time they got a perfect score. But do they get that, or not even one time, maybe a few times? But do they get that most often? Do they even get near that most often? So kind of just depends what you want. In this case, we might look more at the median score, because this is skewed in what direction? Is it skewed? It's right skewed. So when it is skewed, or in other words, not symmetric, we look at the median over the mean. All right, I am getting a little concerned because these are things we talk about almost every day, and the unit test is on Wednesday. This is our last lesson. It should be coming together. It should be automatic. When I use the mean, what else do I use for variability? Standard deviation and math, right? Because mean is in the name, mean absolute deviation. When I use the median for center, what do I use for spread? IQR. It needs to be like, you need to know it. And also, on a side note, now that that's up, in Schoology, I do have a link to the glossary, which I'll usually put for the units anyway. So like all the definitions laid out. You usually don't waste time writing the definitions, you usually just apply them. But I also linked a Quizlet that is already made. So you literally can just go make an account and it's already made for you. You can do the flashcards on your phone. On the Quizlet app. And so forth. So super great. Categorical data, data where the values are categories, like what types of trees, blah, 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 blah. Because clearly we're not like recalling like just basic definitions, basic errors that you should be thinking of. You need to get it by Wednesday. So questions on the warm-up. Okay, so first test style question, if you will. You're gonna answer this on your paper. You have the marathon runners from each of two different age groups have their finishing time represented in the dot plot. You're gonna figure out in your groups which age group tends to take longer and which one has more variable finish times. Since that's 2 questions, I'll give you 2 minutes. All right, the longer this takes is just 2 questions. You shouldn't take this long. So table 8, what's your answer? You literally have 2 answers, 2 options. Let's go.
The first one we chose was 40 to 49 because there's not dots in the 32. There's not a lot of dots in the. Okay. We chose 40 to 49 because in the 32 49 dot plot there's not a lot of like no dots in the 400s and there's a lot of dots for 40 to 49.
Okay, good, so they do take longer then, if they're taking upwards of like 400 minutes, then yeah, this age group takes longer. So I could put, because the data is more to the right, or something to that effect. All right, simple as that. Questions on it? You may be able to justify it. To the right of the number line is where the numbers get higher, traditional number line. I know on a previous quiz, some people were confused because they asked like, for like a race car, I don't know, time. They were asking what driver had the best time. Well, the best time would be whoever took like the least amount of time, right? So just make sure you know that, like, obviously, if you're taking longer, you're not the best. Okay. All right, moving on. Table 9, number 2, which age group had more variable finish times?
43, 40,
And what's your justification?
because they're more spread out evenly, unlike the 30 and the 9.
Because they are more spread out. All right, what does variability mean, class? How spread out it is, more people should be answering. Like, if we don't know what variability describes, like, I don't know what to tell you. So many questions on just that. Which one is more variable? The one that's more spread out. 40 through 49 starts at about 250. Ends at about 450. You can do the math, but also visually you could see. The other one starts at about 230, finished by 380. Way less spread out. Questions on it? Okay, so then moving on. Now the next activity. You have each of these data displays are kind of grouped. What you're going to do is decide what is better to describe the center and what is better to describe the variability. So again, measures of center are what, table 1? Measures of center are what? Talked about it like 5 times already today. I'll come back to you. The question is, what are some measures of center? I'll come back to you. Table 1. Table 2, what are some measures of variability? One more. All right, one more that we're missing for variability class. You can say it. Okay, good. Now back to you, table 1. What are some measures of center that tell us where most of our data is clustered around? A mean. And one more major one. Perfect. Everyone star, highlight, do what I do, like this is printed for you. Measures of center, circle it, be like mean and median. Measures of variability, IQR, standard deviation, math. Now, when do you know which is best to use and when? So like, when would I prefer the mean over the median? Okay, so I heard both answers. So when it's symmetric or not symmetric for the mean?
Symmetric.
Okay, good. So maybe write that somewhere too. So when the data is symmetric, use mean. And then when we have symmetric data, what would we like to use for the spread, for the variability? These are my options. If I have symmetric data and I use the mean, I would want to use what for variability? if I'm using the mean for best measure of center, what's the best measure of variability? Anyone? Jasmine? The MAD? And then what is really similar to the MAD? Okay, good. Yes. Well, I haven't been aligned, or I think it's good now. So symmetric data, mean, MAD, and standard deviation. I'll even specify, use mean for center. MAD and standard deviation for spread / variability. Put on a note card, start highlighting it, whatever. Put it under your pillow, read it every night before you go to bed. All right. Now, when do I use the median and IQR? When the data is, okay, good. So then not symmetric or skewed. You will use the median and the IQR. I think the best way to have it memorized, like instead of just memorizing random things, is to understand why. All right, we talked about it before. I still need to give you time to do the activity. So, in your groups, you are going to have a discussion about each data set. So like for data set 1A, you're gonna decide, will I use the mean or the median? What do you think? Mean or median? Mean, why? Okay, good, it is. And since I'm using the mean, what will I use for spread? MAD and, okay, good. You'll do that for each individual data set, even the ones with words on the bottom. And then once you've done that in each group, so like the ones that start with ones, you will decide which one would have the higher mean or the higher standard deviation based on its distribution. If you forget, the instructions are at the top. So you're determining what's the better measure of center and spread, which one has the greatest center, the greatest spread, and then just be able to explain it. I'll start with 5 minutes for you, and then we'll see where we're at. All right, go. Three. Table 3 for 1B, which is better, mean or median? And then what measure of variability is better? MAD and standard deviation. As we go through these, if you disagree, please raise your hand and we can talk about it. Otherwise, we're all assuming we're all on the same page. Okay, why is the mean, MAD, and standard deviation better, class? Symmetric. Even if it was just roughly symmetric, we would still go with the mean, MAD, and standard deviation. So there we go. Between these two, which one would have a higher mean? Okay, why the first one? Just guessing or? Because you did the math or?
No,
Okay, how do you know just by looking at it? I'm not saying you're wrong.
I just have visual skills.
Okay, help us with those visual skills.
Well, it has like one dots. Like it has higher dots.
That's not what makes it a higher mean, although I will say the mean is higher for this one than that one. They both have negative. Try again. What is my mean approximately for the first one? Brooklyn? Oh, did you do the math? Oh, okay. So the mean is approximately negative 8.4, you mean?
Yeah, that's what I meant.
And then what's the mean approximately for this one? Did we do that one?
Wait, what?
What's the mean approximately for that one?
Negative 10.
Okay, so this is how you can visually estimate the mean. Won't always be exactly that, but since my data is symmetric, my mean should match like my median, essentially. For the middle, isn't it about negative 8.4 over here? And then on this one, my middle is about negative 10, and this happened to match it. Assuming that we did the calculations right. So what number is higher, about negative 8 or about negative 10? Thinking those are negatives. So that's why 1A has a higher mean. So make sure you put that. I put a little arrow. That mean is higher. Which one has a higher MAD or standard deviation? A or B? What does standard deviation and MAD measure? How spread out it is. So which one is more spread out? A is. So this one has a higher mean and a higher MAD standard deviation. Because more of the data is on the ends versus around the mean. It's farther from the mean. On this one, they're all centered around the mean. Questions, comments, concerns? Okay, so yes. Go ahead. Guys, we need to stop asking during lessons, so let's try to do that. All right, table 4, number 2A, which one's better, mean or median? And then for the variability. Right, good. Table 5, what about 2B, which is better, mean or median? Mean. All right, now, which one do you guys think as a class would have the higher mean? Just looking at it.
Do it.
Okay, 2A, I would tell you, has a mean of about 20. Because that's where my middle is. What's my mean of 2B about? About 30. So my mean is actually higher for 2B. Which one would have a higher MAD or standard deviation? The first one, A or B? Okay, one person says 2A. Do we know what MAD and standard deviation measure? So which one's more spread out, A or B? A. This one goes from 13 to 27. This one goes from 27 to 33. This one's closer together. This one's farther apart. So yeah, questions? Let's get better at it. We're learning, but now let's get better at it. It's pretty much the same. Now let's see. Table 6, 3A. Would we use the mean or the median?
Which one?
3A.
The median and the IQR.
Table 7, 3B. Would we use the mean or the median? And then for spread. All right, good. Because are these data sets in set 3 perfectly symmetric? Are they even roughly symmetric? What would you say they are? What's the proper name for not symmetric? They are skewed. So this one on the left is left skewed. If the void's on the left, this one is right skewed. Which one do you think would have a higher median? A or B? All right, I know it's not symmetric, so it's not going to be perfectly in the middle, but median literally means middle number. So where is my data mostly clustered around for the first one? Like over here. My median's probably going to be somewhere over here. What about in 3B? Where's my median gonna be around? What numbers are bigger, 8, 9, or 10, or 1 and 2? 8, 9. Okay. So 3A would have a higher median. Which one would have a higher IQR, A or B? Better at it. Which one's more spread out, A or B? A. IQR is a little tricky. You might actually have to do the math for it, but just visually looking at it, I would also go with A. There's not as many like random outliers. It's like all just pretty widely distributed versus this one that's closer together. Okay, questions? We good? Now, table 8 for A, mean or median? Mean. And then what for the spread? That and standard deviation. Table 9 for B, mean or median? For B, mean or median? And then what for the spread? Okay, good. Which one do we expect to have a higher mean, class? A. Most of the data is centered around the 100 here versus, I guess my middle would be somewhere around here. 100's bigger than about 90. Which one is more spread out, you think? The bell shape or the uniform? Very good. The uniform is more spread out. Why, you might ask? Well, these are more centered around the mean, and then it gets lower the farther it gets. These are the equal amount of spread on each point. So that one's more spread out. Bell shapes are usually less spread out, the same. Okay, moving on. Now the box plots. Still similar to your dot plots. If you can draw a line down the middle, and middle would be our median on the box plot, so this middle line. If it looks the same on both sides, or at least really close to the same, then it's symmetric. Would you say that this is symmetric? No, one whisker is longer. The median is not perfectly in the middle of the box. So median or mean for that one? Median. This one would be right skewed. So if we're using the median, what's better for spread? IQR. Table 1, back to you. 5B, median or mean?
Median.
Median. And then for the spread?
Mean.
Mean is a measure of center. So for, sorry, what? No, we're on 5B still. For the spread of it, what's the best measure?
What's it called? Standard, whatever it's called.
Could I ever have it be like, if median's better, standard deviation's better? Have we seen that trend at all up here? So it's almost like they're in individual groups. Okay, so here's the key again. When it's not symmetric, you're right, we do use the median, but we should use the what for spread? IQR. So put that in your brain, write it down, read it every night, put it on a poster, hang it up on your wall. Median and IQR. Then better. Since it's not symmetric. Now, which one has a higher median, you think? Anyone can talk? Okay, let's see. Their median, which you can actually tell for sure because it's marked on your box. Their median 700. This one is 500. So yeah, A has a higher median. Which one would have a higher IQR? A or B? Bonus if you can tell me without actually doing the math. 5A or 5B? Okay, 5A. I was confused. I was like, there's 2 5s. Yeah, so this box is longer. IQR is Q3 minus Q1. Here's Q3, here's Q1. So the smaller boxes have smaller IQRs. All right, good. Now the word. I know you like to skip these because you don't like reading or whatever. They're not that hard. Like you have to get through it. Something you have to work on. So we have a political podcast has mostly reviews that either love the podcast or hate it. How would you expect that dot plot to look? What do dot plots that are usually used for? Ron?
Higher, either higher, really high or really low.
Okay, so say it's on a scale of 1 to 5. If they either love it or they hate it, where would my dots be?
Outside.
On 1 and 5, so something like this. Would you say it's symmetric? So mean or median? Mean, and then standard deviation or IQR? Good, and that too. I'll put that right here. So you have to visualize how it would look. So then 6B, a cooking podcast has reviews that neither love or hate the podcast. So let's pretend again, scale of 1 to 5. If they neither love it or hate it, where would we imagine most of the dots are? So something like this. Maybe even like 1 or 2 over here, who knows? They didn't really specify. Is that mostly symmetric, you think? So mean or median? Mean. If it's mostly symmetric, that'll still be the mean. And then standard deviation, IQR. Good, and that, they're really similar. All right, questions on that? Okay, so 7A, stress testing concrete from site A has all 12 samples break at 450 pounds per square inch. So even if you have no clue what they're talking about, they're telling you all the samples break at the same point. Would that be symmetric or not? So mean or median? And then what per spread? Okay, good. If you got that your first try, great. If not, fill it in. 7B, stress testing concrete from site B has samples break every 10 psi, starting at 450 until the last score is broken at 560. Do you think that would be symmetric? It's breaking at every 10, so it would be like dot here, dot here, dot here, dot here. Pretty symmetric. So mean or median? MAD or standard deviation or IQR? Okay, good. Last one, stress testing concrete from site C has 6 samples break at 430 and the other 6 break at 460. Symmetric or not? Okay, well then maybe let's draw it out. If 430 is over here and 460 is over here, and there's 6 samples breaking on each, pretend that's 6 dots. Is that pretty symmetric? So mean or median? Standard deviation or IQR? So are we seeing the pattern? Could it ever be median and standard deviation? Could it ever be mean and IQR? Okay. So good. Sorry you didn't have much time in class for the practice. Still get it done. I have faith in you. All you have to do over the weekend is any of your missing homework and getting your finer check ready. We don't have a quiz on Monday. We have a test on Wednesday. Yes.
Oh, over. I do like.